All right, let's look at exploration 2, a power series for cosine. Construct the sixth order Taylor polynomial and the Taylor series at x equals 0 for cosine x. So let's begin by remembering what the Taylor series at x equals 0 is, and I've written it here. F of x is equal to the summation from k equals 0 to infinity of the kth derivative of f evaluated at 0 divided by k factorial times x to the k. And the sixth order Taylor polynomial will be the first 7 terms of this series, going from k equals 0 to k equals 6. So to construct this, we will need to find the first 6 derivatives of cosine x. But let's think for a minute here, and maybe we can be a little clever. So for instance, what is the derivative of cosine x? Well, it's negative sine x. And what's the derivative of sine x equal to? Well, cosine x. So our derivatives here are going to be alternating sines and cosines. And if we're going to evaluate them at x equals 0, what's the sine of x equals 0 going to be equal to? 0. And what's the cosine of x equals 0 going to be equal to? 1. Well, what does this tell us? It tells us that the odd k terms are going to be equal to 0. But let's work it out just to be sure. So we have that f of x is equal to cosine x, and we are going to evaluate that at x equals 0, and that's going to give us 1. And then we're going to have f prime of x, and what's that going to be equal to? Well, negative sine x, and we're going to evaluate that at x equals 0 and get 0. We've got f double prime of x, which is then going to be equal to what? Well, negative cosine x. And when we evaluate that at 0, we're going to get negative 1. So on top of the odd k terms disappearing, we're also going to have an alternating sign here, SIGN sign. So our third derivative is going to be sine x. And when we evaluate that at x equals 0, we'll get 0, just as we suspected. Our fourth derivative is then going to be cosine x. We're going to evaluate that at x equals 0. And again, that's going to give us 1, our alternating signs. The fifth derivative is going to be negative sine x. We're going to evaluate that at x equals 0, and that's going to give us 0. And finally, our last derivative is going to be negative cosine x. We're going to evaluate that at x equals 0 and get negative 1. And that completes our pattern of alternating signs. So on the next screen, I have written out the sixth order Taylor polynomial, and we can just substitute our values in. So f of 0 was equal to 1. F prime of 0 was 0. F double prime of 0 was negative 1 over 2 factorial times x squared. F triple prime was 0. The fourth derivative was positive 1 over 4 factorial times x to the fourth. The fifth derivative gave us 0. And the sixth derivative gave us -1 again over 6 factorial times x to the 6th. And we can clean this up a little bit. So we get 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. So that gives us our 6th order Taylor polynomial. And then the last thing we're supposed to find is the Taylor series. And that is going to be the summation term. So that's going to be equal to the summation as k goes from 0 to infinity. And we're going to have x to the 2k because we only have the even powers. That's going to be divided by 2k factorial because whatever the power is up here is also what we're taking the factorial of in the denominator. And then finally, our signs are alternating, and we take care of that by -1 to the k. Now, you should compare your method with a classmate's and see if one of you came up with some different ideas.